Good day, viewers. As you already know, my name still remains Israel. In our last video, we discussed we had a little hint about how this our WAEC is going to look like. We talked about exhaustively, actually, about SWOT analysis. And I told you that we also have another video on volumetric analysis, also called titration. So, in this volumetric analysis, we are going to have a look at some of the solutions. One of them is potassium tetrazomanganate 7, usually called also known as KMNO4. That's the formula. Then we have the other one, iron 2 tetrasulfate 6, FeSO4. So remember, when you are using this kind of performing this kind of titration, which is actually a redox reaction, you don't need an indicator because the KMNO4 is a self-indicator. So having said that, let's go straight. But remember, before you can carry out this titration work, you must acidify it using 10 cm³ H2SO4, which was taken from 1 molar solution of it. So let's see how the question goes, so that I'll go straight to the point. Solution A contains KMNO4 of unknown concentration. B is FeSO4 solution whose concentration is 0.025 mol per dm³. Titrate out 20 or 25 cm³ portions of solution B against solution A. Tabulate your readings, and from your result and information provided, calculate the average volume of A used. Concentration of KMNO4 A mol per dm³, B gram per dm³. This is the equation. So remember, this the one that we're able to frame from this side. This doesn't mean everything will come out word for word, but to give you a guide so that you will not be stressed, you will not be stranded when you are in the hall. So please understand it properly so that whichever way they bring the question, go to interpret it and so solve it accordingly. But I will also advise you, you should read wide, not just narrow your mind on this, also read wide. Like I said, this is just a guide. So to start, it says solution A contains KMNO4 of no concentration. B is FeSO4 solution whose concentration is this. Titrate out 20 or 25 cm³. So the one we use in my school, like I told you before, is usually 25 cm³. If your own is 20, you must indicate it. You say volume, shift it up, volume of pipette 25.0 cm³. Then you now draw your table, titration table. If you use capital letter, it doesn't matter. Use small letter, capital letter, anyone is okay. So you have it here. I advise you to always draw 3. You have something like this, something like this. You have here rough, first, second, cm³, cm³, cm³. You must always indicate it. Final burette readings. Initial burette readings. Volume of acid used. So this is how you draw your table. As you progress, you start entering in the values you're having from the reading of the burettes. So this one you can start with 0.00, 0.00, 0.00. If you want to know, as if you have your solution is not more enough, go to my first video on how to carry out perfect work on titration. So that is how it is. When you are writing this, there's also some precautions which I promised to teach you. Even though I already explained in the first video, make sure you go through that first one before you go to your hall. So like this, remember this one in WAEC, especially NECO, scores 1 mark just for identifying the volume of pipette you are using, because all of them varies. So you have some 20 and some 25. Those are the 2 permitted ones in secondary school. Then you have this final burette reading. Remember, it must be 2 decimal places. On no condition must you put it to 1 decimal place. With to 1 decimal place, they deduct your mark. So let's go with titration. As we progress, we'll be explaining more. So this is our conical flask. Let's titrate it. Let's measure it out. Remember, no matter the endpoint, how beautiful it may be online, you must not use it. Use the one that you are given in your school. The way your teacher, your teacher explains to you in your school is the one you will use. If you are giving anyone in your school, you use it. The way you explain it is what you are going to use. That's the endpoint. The rest are okay. But for the endpoint, on no condition must you use the one you get online. Even from the one I use here, you must not use it. Use the one that is given in your school. Because if I have 20, let's say I have 22.0 or 15.0, and your school has, the one your school is using is about 30, and you use 15, is 0. That 11 mark, which is almost a bonus mark, 8 marks out of it is already 0. So don't fall into that mistake. Don't make that mistake, actually. Use whichever one your teacher uses in your school, or the way he teach you to get your endpoint. The way your teacher teach you to get your endpoint, that's what you should follow. So we have had this one. The next thing is to acidify it. If you don't acidify it, it will not be able to change, because you normally use acidified KMNO4, but in this case you have to acidify this so that it can produce the color change. So this 10 cm cube, as I told you, I just pointed to it. Remember, the salt that is available in the market. So that's what I'm telling you. Anyone your teacher give you is what you use. Even if he give you 10 cm cube, that's what you should use. You have the hydrous FeSO4, which is very rare to come by. Then you have the hydrated one, pentahydrate, is what they said all over. So whichever, both of them cannot give exactly the same endpoint. So I've already added it. You swine it, shake it very well, then start titrating. That is why I said whichever one you see is entering. You see it, see the color. Then when I shake it, it turn back to colorless. So that is what you do. Whichever one they give in your school is what you take. You can see the endpoint. I've gotten the endpoint for this. So this is the endpoint here. So for the purpose of this titration, we are going to use an endpoint of 19.3, and we are not going to repeat it. So this, let's say the first one is 20. .40. The one we are using now is 19.30. So let's say the second one is 19.30. You see it. This is how you draw your titration table. See the first one, 20.40. The other one, 19.30, 19.30. On no condition must you write 19.31. You understand? Because there's no calibration like that. It's actually 19.3, but you make it 2 decimal places so that you score all your mark. So when you have this one, you look for the one that is concordant. Concordant means it does not differ by more than plus or minus 0.2. 0.2 is what they normally use in WAEC. However, NECO use 0.1 at times, 0.15. So for this WAEC, 0.2 you are going to use. So if you subtract, you have 19.30, you have 19.30, you have 20.40. Why I'm using this value is because you are not going to use it in your school for your WAEC. Use the one that you have in your school, or the method your teacher teach you to get your endpoint. Like in my school, as I've done it, my student does it, they will have the same endpoint or similar endpoint because they know how to do it. So use the same method in your school. Now we have this table now. When they are marking it, this one scores 1 mark, this one scores 4 marks because they are concordant. If you by any chance use this, it's wrong. So let's add it together. These are the two concordants, any you for 4 marks. So you have average volume of acid use. In this case, KMNO4 is acting as solution A, acid, and this FeSO4 acting as solution B, which is the base. So average volume of acid use is 19.30 plus 19.30 over 2. Let's see what it gives us. 19.30 plus 19.30. 19.30 give you 38.6. 38.6 over 2, which gives you 19.30 cm3. You see, to 2 decimal places. I told you, no matter the book you use, this is what is accepted. 19.30. That's to 2 decimal place. This is where 2 decimal place ends. Any other value you have from here is 3 significant figures. Don't make mistake. So this is what we have for now. Then let's look at the question. Average volume of acid use, which I've already calculated. This is A. Second one is concentration of KMnO4 in solution A in mole per dm cube. So let's clean this one off. So we clean this one. Solution A contains KMnO4 for no concentration. This FeSO4 concentration is this. We have Cb, we have Va. Then, so we can use the method normally called cover. That's the formula I normally use, the formula method. So if you are using the formula method, you must write the equation. You say equation MnO4 minus plus 5Fe2 plus 8H plus to give you Mn2 plus 5Fe3 plus 4H2O. So this is the value you are going to have. So when you have this value, you know that the mole ratio, it does not concern this one. This one is mainly used for acidification. You see H plus, meaning you are protonating it from H to SO4, gives you this H plus. I remember we said in one of the videos we did in theory, a proton is a hydrogen that has lost one electron. So it only dwell at the mercy of the proton that's inside the nucleus. It doesn't have negative charge because it lost a single negative charge. So that's this one to cause the reaction to occur. So you now have mole ratio 1:5. So you now say from the formula Ca Va Cb Vb Na over Nb. Sometimes the space you are giving your booklet, because it's usually typed, the space you are giving is not enough. Most of us, some students, they rule it. You rule it. When you rule it, you can write on this side and write on that side. On no account must you carry a question that from the space provided to another space is not acceptable. Even if you carry it to the back, it's not allowed. You will have to manage that space you are giving. Therefore, what students do is they share it. And again, another precaution so that I don't lose your marks as my subscribers, as my students. These are the little secrets that sometimes when students say, I'm very intelligent, this thing is very simple, I did everything. At the end of the day, they don't pass well. Some can fall into the lowest grade, C6. Some can even fall into D, or maybe even fail it outrightly. So the reason is because they did not know the precautions they are supposed to follow. They depended on textbook method. They are not working with those in the field. Those are the examiners that mark. So like this table, the table I gave to you before, on no account must you cancel. On no account must you cancel. If you cancel cancellation, you lose 4 marks. Once you lose 4 marks, but it is applied only to the table. That is one. Another condition is, another thing you may incorporate to, you must not use pencil. If you use pencil, you must delete it completely, that it's not traceable. Because if you use, so instead of that, know what you are doing. If you use pencil, not just there, but on any part of it, both this one and others, they write WIP. WIP means, the acronym is WIP, W-I-P. Writing in pencil, you lose 2 marks. Why would you be losing your marks? Then if you alter, let's say on that, but the alteration is purely dependent on that table. Let's say when you are writing 19, like this 19 now, 19 point, you wrote 19.0. You now remember that it's not actually correct. You now change it 19.2. You see it, they circle it and remove 2 marks. And if you cancel the table completely, you want to rewrite on that table, you lose 4 marks. So note those things so that you can do well. It's not actually a matter of you know it too much or you know it very well and you forget these precautions. You have to take this precaution very seriously so that you don't fall prey. Now you have this, you have Ca, Cb, Va, Vb, Na, Nb. This is applied to chemistry. I don't know for that subject. Then you have a Ca, you don't know. VA is what we just calculated, 19.30 cm cube. CB is 0. But again, when you are calculating, my friends, what you do, check if this 0.025 mole is per dm cube. If they say per 500, standardize it. Go through my previous video, see how to standardize, so you don't lose your mark. If it's in per 500 or per 200 and you work with it, you lose everything you did in that column. Usually 4 marks, you lose it. And substituting wrong value again, you still lose another mark in terms of accuracy. Therefore, you must check it very well. If it's in 250, standardize it by multiplying by 1000 and dividing by that 250. If it's in 500, multiply by 1000, divide by 500. You will get 2 marks there for that standardizing. Then substitution, you get other marks as it applies. So let's continue. VB, we said VB, volume of base, is 25.0 cm cube. Remember, this is also VB, volume of base. Then NA is 1. Remember, this A, this B. NB is 5. Then what of CB? Let's see. I said CB is 0.25 mole per dm cube. 0.025 mole per dm cube. So that is the value. The next thing is to substitute. We are already taking this, so we can delete it. So we can say substitute. CA times 0.025 over CA times 19.30, 0.025 times 25 equals 1 over 5. So this is what you have. You now cross multiply it. You say cross multiply. You now have CA times 19.30 times 5 equals 0.025 times 25 times 1. So you now make this sort of formula. CA times, I always advise you to multiply it first. Let's see how it goes. That's 19.3. 19.3 times 5 give you 96.5. 96.5 equals 0.025 times 25 times 1. CA will now be 0.025 times 25 times 1 over 96.5. My dear friends, another thing you need to know is this. You can see the value I have. This value, assuming it is approximated, what I do, whether approximated or not, I will punch it 0. Everything will return to 0 once I've written my answer. If you carry, assuming you approximated to given value, and you not punch your calculator to 0, so that you now carry the approximated one, you will lose mark for correct substitution. It means you have something else in your calculator, you have a correct answer there, but when you are not substituting, you substituted but use the wrong figure, because you approximated, because that means you said the one in your calculator is wrong, so you now approximated to 3 significant figures. So that 3 significant figures is what you should carry. You should lift it. When you lift it, you now substitute it, then you get your full mark. But if you lift it there and yet you did not punch your calculator to 0, you lose the mark, because they will always calculate it. So let's see how this one goes. The examiner will always calculate it, so don't think there are very many. They will not calculate. They will calculate everything. So 0.025 times 25 give you 0.625 divided by 96.5 give you 6.4766. 6.4766. 6.4766. I hope we are right. 6.4766. If you write this one, this is just what I said. You write this one for them, they will mark it wrong, because this one is to 1, 2, 3, 4, 5 significant figures, which is not accepted. Therefore, you now say approximately 6.48. mole per dmq, 3 significant figures. Whether you write this or not, they know it's 3 significant figures and they mark it for you. Remember, this place is 4 marks. How is it 4 marks? Correct substitution 1 mark, mole ratio 1 mark, sorry to formula 1 mark, evaluation 1 mark. So if you are the kind of person that calculate everything once, you get only 2 marks. Follow this sequentially. This practical chemistry is different from theory and other science subjects. What you do here, correct, after putting this formula, correct substitution, you put it correctly, 1 mark. That's ability to replace everything you have written here. Then mole ratio, 1 mark, that's 2. Sorry to formula, 1 mark, 3. Evaluation to 3 significant figures, 4 marks. So that is how that one goes. So that's the condition of K-4 in solution A in mole per dmq. So we have done B. This is B. Then the last one is B1. I think this is B1, B2. So this is B1, B2. So B2 said in gram per dmq. I know that mass concentration or concentration gram per dm equals molar concentration times molar mass, which is same as this molar concentration. Is it not for A? Gram per dm cube. Okay. You have 6.48 times the molar mass. But let's go through this calculation again. I hope we didn't make mistake in these figures we have. Let's do it again, please. Okay, 6.476 times 10 to the power of 3 times 10 to the power minus 3. Sorry for that. So automatically it gives us 0.648. So this is what we have. 0.00648 times the molar mass. And they give us molar mass as 158 times 158. This one will give us, you see, I'm turning it to 0 again. I made it 0 because this is what was reflecting on my calculator. If I use this, everything will be wrong. So I now have 0.00648 times 158 give you 1.023. 1.023, which gives you 1.02 gram per dm3. So this is how you carry out calculations of this nature. Remember, this is just a sample, it's just a guide. So, but if you study it very well, I think it will help you a lot in your forthcoming WAEC as regards volumetric analysis, also known as titration. Remember, all the questions that may not be tied to this. This is just my own assumption. You have to read very wide. Nobody knows where the question is coming from. But from experience, this is my assumption. Remember, they can also tell you to calculate the number of moles of the base in the volume of B pipetted. You want to solve those ones. You shall want to solve it. You have to convert the volume of base, since it's per dm cube. dm cube, you see 1000 contain this, 25, which is volume of base you pipetted, contain S. It's as simple as that. So thank you, my viewers. As I said, this is a gift for those of you that have been subscribing, and also those that have been watching my video. Please, I appeal to you, continue to watch my video and you see a lot of things. I pray the good Lord will help us so that all this effort we are putting into it will not be wasted. God bless you. Please kindly press the like button, subscribe, and also share as you have been doing. Thank you so much.